Hello students, welcome back. Today we are going to start a very interesting topic, which is light, reflection and refraction of light. So in this chapter we will discuss about all the phenomena related to the light, reflection and refraction. But in this class we will discuss about all the concepts of light, what is the characteristics of light, what is reflection, what is refraction, how the physical phenomena can be defined with the characteristics of light. Okay, so hello students, welcome to Physics Orbit. Let's get started. First you have to see that light, reflection and refraction. First of all, we have to know what is light. If I ask you what is light, then some of the students will answer that light is a ray, and some of them will answer it is a wave. So what is light? We know that light is a ray, but most of the physical phenomena can be explained with the wave nature of light. If you say that light is a ray, then most of the physical phenomena can be explained with it, but some of the physical phenomena of light cannot be explained with the straight line propagation of light or light as a ray. To explain those phenomena, we have to understand the characteristics of light, that is the wave nature of light. Okay, so if I say that light is a wave, so at the starting of 19th century we came to know that the light is a wave, but after that, after the birth of quantum physics, some of the well-known experiment like photoelectric effect and some other phenomena, those phenomena revealed that light is not only a wave, it has some properties like particles. Okay, so we have to know that light have both characteristics. It has wave-like characteristics or it has particle-like characteristics. So we can say that light is a wave or it is a particle, stream of particles. But we will not discuss about the particle nature of light, because it is a concept of quantum mechanics or quantum physics. You will see those phenomena in the higher classes of your higher studies. And wave nature of light is related to the diffraction of light, what we will discuss later. So in this chapter we will discuss about the straight line propagation of light or rectilinear propagation of light. So we will consider in this chapter that light is a ray. Okay, so it is a ray. This is a preliminary concept by which we can define the reflection of light, refraction of light. So we will consider it as a ray. So if I say in our physical world, so what is the function of light, how we can see all the things around us, because in the daytime you can see all the things around us, but at the night time without the source of light you cannot see anything. So which phenomena makes it visible to us? So we have to know that what is the function of light, what is the characteristics of light. So next we will discuss about what is the characteristics of light. If I define light as a wave, so it has some frequency which makes us visible to our eyes. I already have said that light is a wave, but what kind of wave it is? It is a electromagnetic wave. It is a electromagnetic wave. Okay, you have learned about the wave like sound wave. So sound wave is one kind of wave which propagates through a medium, but light is a wave which can propagate or which can travel through a vacuum. So to propagate sound from one place to another place, medium is required, but to propagate the light wave from one place to another place, no medium is required. Okay, so you have to know that light is a wave which is an electromagnetic wave, but it requires no medium to travel from one place to the other place. Some example you can take here, that light coming from the sun through the vacuum and enters through the atmosphere of the earth. So in this path there is no medium from the sun to the earth, but light can travel from vacuum. That's why it can travel from one place to another place without any medium. But if you take sound as a wave, sound wave is such a wave that requires some medium to propagate from one place to other place. Okay, one question arises here. If I say that light is a wave, so how can it travel from one place to another place without any medium? You will learn about that in your higher classes, because it is an electromagnetic wave. I have said that it is an electromagnetic wave. So electromagnetic means some electric vector and some magnetic vector are related with it, so that's why it does not need any medium. So we will learn about that in some other classes. So first of all, you have to know that light is an electromagnetic wave and it has some frequency. So what we see in our physical world, that is light has 7 colors from red to violet. So red to violet, it has some specific frequency. You can see in this picture that a light coming from the sun, it has some specific frequency in this frequency band. You can say that the frequency range, this wavelength range from radio frequency to the gamma ray, from radio wave to the gamma ray. Here all the frequency are electromagnetic waves. Okay, so the maximum frequency it has gamma ray, so the wavelength varies from radio wave to the gamma ray. So what is the light stands here? Light stands here from 400 nanometer to 700 nanometer. So what is the visible range of light? What we see in our naked eye, that a light have red to violet. Red have 700 nanometer wavelength and violet have 400 nanometer wavelength. Okay, so this is the visible range of light which you can see in our naked eye. But electromagnetic wave have a frequency range, have a wavelength range from radio wave frequency, radio wave to the gamma ray. So it has a vast frequency range. You can see that in this chart that the visible light have a wavelength ranging from 700 nanometer to 400 nanometer. You have to remember that. And the higher frequency electromagnetic waves which we cannot see are some electromagnetic wave, ultraviolet, gamma ray, X-ray. Those are also electromagnetic waves which we cannot see in our naked eye. Some of the waves coming from the sun, which is ultraviolet ray, which we cannot see in our naked eye but harmful for our skin. So these things you have to know about the electromagnetic wave. Okay, so which makes things visible here, that the light ray coming from the sun makes things visible in daytime. Okay, after that we will see some natural phenomena related to the light, which we call the reflection of light, refraction of light and diffraction of light. So we will learn about reflection of light and refraction of light. So some natural phenomena we see in our physical world, that is reflection, number 2 refraction, and number 3 diffraction. You have learned about the reflection of light and the characteristics of it. So what is reflection? If I say what is reflection, you will say that light coming from one medium and reflected on a highly polished surface like glass or mirror, then it reflects back, then it's coming back to the same medium in the same angle, which is called reflection. Okay, so we will see that. So what we see in our physical world, that is reflection. So you can see that the reflection of light or reflection of your image in the lake water or in the pond or in a swimming pool. So this phenomena is called reflection. This is, you can see here, it is a refraction. You can see that the light ray, the beam of ray coming from one medium and entering to the another medium, which is glass. It is a glass, and it bends in another direction. You can see here the path was in that direction, but it is going to this direction. So it is a characteristics of refraction, and when it emerges from the glass to the water, it goes to the another direction. So here it will turn in some angle theta, which we will learn in the refraction chapter. So this phenomena is called refraction. This is refraction, bending of light from one medium to another medium, which we call refraction. And what is the third phenomena? It is the diffraction. So what is diffraction? Diffraction is a phenomena, if you take a candle, it will illuminate all the way surrounding it. If I take a sharp edge object in front of it, then the shadow will form in some blurry way, because it should be as light propagates in a straight line, it should be like a sharp shadow. It should be like a sharp shadow. But in practice we see that some of the light coming in this region, in the shadow region, and some of the shadow going through this region. Okay, that's why the shadow is not sharp here. So this phenomena is called diffraction. This is diffraction. we will discuss about diffraction in higher classes. To define diffraction, we have to discuss about the wave nature of light, which is not included in your syllabus. So we will not discuss about diffraction in this chapter. We just discuss about reflection and refraction. So in this chapter we will only discuss about the straight line propagation of light. Straight line propagation of light. Okay, we will discuss about the reflection of light. So what is reflection? I have already said, if I take a candle here, it is a candle, then light will emerge all the way from the candle. So if you take a mirror here you take a mirror, so what will happen? The light will fall on the mirror and come back from it. So the angle here is called the incident angle, and the angle is here is called reflected angle. So here incident angle I will equal to reflected angle R. So if you see from here, you will see the candle at the back side of the mirror. How is it possible? The candle is here, but if you see from here, the image of the candle will form at the back side of the mirror, which will be in same side, like that. So if we try to define it, how can we define that? See, the light is coming from this candle in that direction and reflects back in that direction. Okay, you can see from here that the light is coming from this direction. You can see the candle is here. So this is called reflection of light. So we will see the two laws of reflection here. Two laws of reflection. Okay, number one, here the angle of incidence is the angle of reflection. Okay, number two, incident ray, reflected ray, and the normal, which is what is normal? This perpendicular, this vertical line is the normal, which we call N. These three things, incident ray, reflected ray, and the normal, these three lines will lie on the same plane. So this is the second law of reflection, and this is the first law of reflection. So what is the first law? First law is the incident ray will be equal to the reflected ray. So if I take here it is a mirror. Light is coming in that direction, which is making theta angle with the perpendicular, and going through this direction, which is same angle theta. So these two angle will be same. This is the incident angle I, this is the reflected angle R. Okay, these two angle will be same, that is I equals to R. Okay, and these three lines, incident ray, reflected ray, and the normal, these three lines will be lie on a same plane. This xy plane, incident I, reflected R, and this normal, these three lines will be lie on the same plane. Okay, so this is the second law of reflection. Next we will see the characteristics of the image after it reflecting back from the mirror. You can see here the candle will appear at the back side of the mirror, but the size of the candle, that is the height and the width, will remain same. Okay, and the distance from the mirror and the distance of this object from the mirror will be same to the distance of the image from the mirror. Okay, the distance d will be same. So number one, characteristics of the image, it will be virtual, size is equal size. Number three, distance from the mirror is same, distance from mirror is same. Clear? So these three characteristics you can see from here, that the candle is situated here at the distance from the mirror and the distance of the image from the mirror. These two distance will be the same. If you see, if you stand in front of a mirror, if you see that an object is situated at 10 meter from the mirror, you can see the image is behind the mirror 10 meter distance. Okay, and number two, it will be virtual. How can we say that it is a virtual? It is not actual, because the image is forming at behind of the mirror, which is not actual, because you are not standing behind the mirror, you are standing in front of the mirror. Okay, but you can see the image which is situated at the back side of the mirror, so that it is virtual. And these two ray coming from the mirror, after reflection it meets at the point which is back side of the mirror, which is not actual. Actually these two rays are not meeting here, it is coming from here. Okay, so that's why you can say that is the image which form at the back side of the mirror will be virtual image. Okay, and number two is equal size. What we have already said, that the image which will form in back side of the mirror will be equal size of the object. So these are the characteristics of reflection which you can see from here. Okay, so after that we will see the reflection of light from a curved surface which is not a mirror, which is a curved surface that has some curvature, like some spoon. If you take a spoon and you can see your face on the spoon, that you will see that it is a erect, or the size of the image is not equal, which you have seen in the plane mirror. The size of the image and the dimension will be same. But if you take a spoon, shiny spoon, then you will see then if you see your face on the spoon, then you will see that the image is not as like you. Okay, so the image will change, the dimension or the size of the image will change. So this phenomena or these characteristics and the curved mirror or the spherical mirror, these things we will discuss in the next class. So if the surface becomes curved or spherical, then the characteristics of the image becomes different. Okay, these things we will discuss in the next class. So what we have learned today, we have seen the what is light, what is the characteristics of light, wave nature and particle nature of light. Here we have seen the electromagnetic wave, what is the range of electromagnetic wave. So light is the electromagnetic wave, so what is the range of it, the visible range, what you can see in our naked eye. This is a limited portion of the electromagnetic wave. Next we have seen the straight line propagation of light, by which we have discussed all the phenomena like reflection, refraction, etc. So this was the topic of today. If you like this class, then like and share with your friends, and don't forget to subscribe. If you have any problem regarding this topic, then feel free to comment in the comment section. I will see it later. So thanks for watching. See you in the next class.